All right, cool. Well, as we talked about in the invitation, I'm really excited to have Pierre with us here. He's been the author of kind of an amazing number of awesome libraries between Caliban, which I just everyone I see seems to love, and then ShardCake, and I think had a little bit also of the fortune of like announcing ShardCake on like the best possible day. I think it was like literally the morning that Akka announced that they were moving to their closed source model. So I'm really happy to have him here with us to talk about this library and get a chance to kind of see it and play with it. I think it's been mentioned a bunch, but I think it's the first time here we're actually going to kind of look at code and stuff. So yeah, with that, maybe I'll hand it over to you, and I'll try to man the Discord, but we can just take it from here. And yeah, if you have questions, yes, someone asked, questions are better asked on the Discord. I'll grab the Discord link and I'll paste in the Zoom chat, but it's just a little bit nicer there because it's a little more persistent. All right.
Yeah, so yeah, you said I was lucky to announce it the day that Akka announced their license change. I actually was not even intending on announcing it. I was preparing the library. I was just I was planning to basically announce it at Functional Scala 22 in December, and I was just planning to, like, for a few months have it, share it with some friends and like get some feedback and like have it kind of low key. But then they announced their license change, so I thought, well, let's just share it right now because that's the best timing, I guess. So
that's awesome.
Yeah. So I don't know. Maybe should I explain like basically what this library is about?
Yeah, that'd be fantastic.
Yeah. So, well, if people have used Akka cluster sharding before, that's basically the same thing. Well, a different implementation, of course, with some different design choices, but that's basically an alternative to that. If you're not familiar with it, I can explain a little further. So what do we call sharding? So basically, let's imagine that you have a number of servers. Like normally, if you develop something that you want many users for, you're gonna scale out and have a lot of different servers. And there are different approaches. You can be stateless. So whenever there is a request from a client, it goes to any server, and any server can handle the request. If you have a state, maybe the state is shared somewhere like a Redis or something. You get the state, you do whatever you need to do, and you save the state. That's one way. Another way, which is the way we are doing, and that is more relevant to this, is when you have a request from a client, and that request is about some entity, you want a single server to handle all the requests coming to that specific entity. So a simple example is the entity could be a user. You don't want different servers to handle concurrent requests about the same user, because maybe those concurrent requests might depend on each other. Like maybe if two requests at the same time try to consume the same resource, and that they happen at the same time, well, you don't want, maybe the first one can go through, but not the second one. So you need some kind of synchronization to make sure that the first one is successful, but not the second one. When you have multiple servers, when you have a single server, that's really easy. But when you have multiple servers, it gets more complex. So one possible option is to use some kind of lock, like a distributed lock. So the first one will acquire the lock, and then the second one will wait until the lock is freed. And then the second one will get the new state and acquire the lock as well, and so on. A typical approach is to use a database lock, like to basically move the logic in the database, because a lot of old gen databases are basically a single monster server. So all requests actually go to the same server, and it's a bit easier to do the lock there. But then you move, basically you moving your business logic to the database, which is not great in my experience, because it's way harder to test database like stored procedures and so on. So ideally you want all your business logic to be in Scala. So another approach, instead of a distributed lock, is to use the single writer pattern. So this pattern is basically that all requests for a single entity go to the same place. Again, there are two approaches for that. One approach is using Kafka, or an equivalent like other message queues, RabbitMQ or whatever. They have similar functionalities where you have consumer groups that are consuming some topic, and that ensure you that all messages related to a certain key are handled by the same consumer. So that works pretty well. But something like Kafka is good for asynchronous workflows, because you might have some lag between the moment you receive the request and the moment it's actually processed. And Kafka is not super nice when you need to respond. It's really good when it's asynchronous, but when it's more like a request response workflow, it's not the best. You need to make a response topic. So it's not ideal. So that's where initially Akka cluster sharding was a very convenient technology. So it's basically the same, except when you receive a request, you send it to your entity, and the entity will be hosted on one of the nodes of your cluster, in this case it was Akka cluster. And basically Akka cluster sharding is taking care of the messaging, redirecting every message to the proper entity, is taking care of starting the entities and ensuring basically that a given entity is only alive on one node at a single time. So your user X will be only alive in one node of the whole cluster. And because it's actor messaging, it's very easy to respond. So you send your message, it goes to the proper node, you process it, and then you can respond directly to the sender immediately. Okay, so that's basically Akka cluster sharding as the use case. And then why did we decide to make an alternative, basically? So little bit of background. So I'm working for a game company, a mobile game company, and we launched a game in January of last year, and that got quite popular, quite a lot of users. And we started with Akka cluster. So we went to prod with this. It worked pretty well, but we found we started having a few problems with a very high load. The first one was with Akka, all nodes form a cluster. And so when you start a node, the first step is the node is trying to join the cluster. So it's communicating with the other nodes, trying to find them and so on. And there is a system in place to ensure that the cluster basically is always alive. And if there is a network issue, or if nodes cannot communicate together, there is a component that ensures that there is no cluster partition, and this component is called a split brain resolver. Yeah. But then we started having these issues where we found the split brain resolver to be really kind of unstable. So we found that if you add or remove too many nodes at the same time, even if it's not the majority, it was kind of getting crazy, basically the cluster is unstable because you are adding too many nodes or removing too many nodes. And and we found that when the split brain resolver becomes crazy, basically it turn off, like it downs all the nodes of the cluster, and you basically have an outage. So because of that, we found that, so initially we wanted to use like auto scaling and so on, but we found that we are not really able to add like to double the number of nodes at once, for example, because we're afraid that this kind of thing would happen. Also, when we were doing a rolling update, so we update all the nodes one by one, we found that if we update too many at the same time, there are some timeouts, like the rebalancing start becoming slow when you have a lot of nodes. So we ended up doing rolling updates one by one to like be really slow. So it worked, but it made our release process quite slow. Like instead of taking 20 minutes, it was taking an hour and 30 minutes.
Oh, wow.
To update all the nodes. And the thing that decided us really to change, to find an alternative was in like hosted like cloud environment, like AWS, as we are using. You always have sometimes some slight network issues, like loss of packets between some nodes and so on. And we had several occurrences where it triggered the split brain resolver, and it basically found that nodes were indirectly connected with each other. So some nodes could see the other nodes, but they couldn't like all see each other and so on. And basically it downed everything. And we had like a few outages like that. And when it downs everything, it's also a problem because when the node restart, they try to rejoin the cluster, but the cluster is in a very unstable state. So they fail to join the cluster, and basically they keep restarting until someone, a DevOps basically stopped everything and restarted everything, because otherwise so it didn't even recover in a very nice way until there was a manual operation to really like stop everything and restart to form a new clean cluster. I'm sure, I mean, there are probably Akka experts might find some ways to avoid that. Like we try to investigate these kind of issues. But basically for us, Akka was kind of a black box, especially the split brain resolver. There is like the indirectly connected node logic is not configurable. It's not really documented. We try to enable debug logs, but because it only happened with a high number of nodes with high load, there was like millions of logs, debug logs that were not really helpful. So at the end, we wanted to have something that we could like something that we could control with a simpler algorithm. And yeah, so and also we didn't really like the fact that our game servers basically had to form a cluster, like, and that kind of made us a little uncomfortable always. Like we have to worry about the state of the cluster, even though there is already a cluster underneath that is the Kubernetes cluster. So yeah, so that's basically how we started trying to thinking about implementing something else. So we initially didn't implement an open source library. We just made our own component that was kind of tied to our own game server. So the logic about assigning entities to shards and shards to different nodes, it's kind of similar to the logic in Akka, so which is basically trying to distribute shards in a balanced way across all the nodes. But we used a separate component for doing this dispatching. So instead of having the nodes being part of a cluster, we have an external component, and when the nodes start or stop, it's that external component that's in charge of reassigning the shards. And we decided to rely on Kubernetes in order to solve those split brain resolver issues, because Kubernetes is already having its own cluster, and it's already like basically stopping or starting nodes. If there is like, if a node is unresponsive, it's already, it has its own health check and it's already like removing it. So why having another, we didn't want to have another level on top of that, and we just basically reuse that. And so yeah, that's very like overall summary. So we finally in February of this year we switched from Akka to our own solution. And that worked pretty well, actually. We were really happy with it. In terms of performance, we observed that it was very similar to Akka, but in terms of reliability and also the speed of like being able to do rolling updates in a fast way. Now we are using auto scaling. We can like double the number of servers if we have sudden peak and so on. So that turned out to be really much better than before. And then in September, well, actually a bit before that, we decided why not open sourcing this, because I think this is a pattern that is really useful in some cases. And we thought our solution is pretty cool. It's also like FP friendly because it's all developed with Zio and some other libraries in the Zio ecosystem. So yeah, we decided to basically extract this part from our own code and make it separate so that we could share it with other users. And yeah, we opened it in September. And maybe a month after, we actually switched our code to use the library. Because when we first released the library, our code was still was not using it yet, but now it is. Now it's really using the library. All right, that's like a brief overview. I didn't check. Maybe let me check if there are some questions.
Awesome. Yeah. Let's see. I think we're. No, I think there's some talk with the audio, but I think just some person. Okay, so one person. So Thomas Nicholas says, does each entity run at most once at any time?
Yes, at most once. So if there is so it's basically 0 or 1. Like if there is if a node is suddenly unresponsive, like we wait until like basically either it comes back or Kubernetes decides that the node is out and is basically gonna like stop the pod in order to like reassign the entities to somewhere else. So it's really a guarantee that it's never gonna be in two different places at any time, which is the guarantee we need for our business logic, because otherwise there might be some illegal things happening.
Right. And yeah, I think you had a follow-up question. So how do you ensure it? But
yeah, so
yeah,
but basically that component that I said, like we have an external component which we call the shard manager. So basically when a node starts, it registers itself to the shard manager, and when it stops in a clean way, it unregisters itself. So the shard manager knows like basically all the nodes that are live. And it's in charge of assigning basically shards to those nodes. And so when it assigns, when it moves a shard from one node to another, it first unassigns it from the old node. And only when this is like done and it receives a success response from the old node, it moves it to the new node. So that way we basically ensure that they are not handled by two different nodes at the same time. Yeah, this is a so well, this is a little maybe vague, but if you want to have more detail, I encourage you to, well, first in 2 weeks at Functional Scala, I'm going to talk about this in more details with some material and yeah, more visuals. And also, I encourage you to, if you're interested, to look at the website with the documentation, because there are way more details. So yeah, this is probably going to be, there are some diagrams, and there are some detailed workflow, what happens when a node starts, when a node stops, when a node is unresponsive, and so on.
Great. Yeah. So I think a couple of follow-up questions people had on that, and some of them, whenever you feel like it makes sense, we can just kind of defer them. So Thomas had a follow-up of, could there still be some database query that's still alive where Kubernetes already proclaims the node is dead?
Well, I think we rely on so there are different status in Kubernetes of a node. Like currently, I think we are using the most conservative, that is the node is like gone, because there is like a pending state. Like we discussed about should we move the shard if the node is in pending state, for example, but we basically just move it when it's gone. But that can be configured, like, because people might have different like needs. Like in some case, it might not be so important. Which actually I want to, yeah, there's a question that says, since we rely on Kubernetes,
Right. Yeah, I was gonna
dependency
do
on
that.
Kubernetes, right?
Yeah. Yeah.
So
I don't
that's
think
one point
that's
that I
quite
wanted
right.
to touch down with. So we are using Kubernetes at work. So the initial implementation was directly using Kubernetes. When we moved our code into an open source library, there are 4 different parts of the system that we extracted into interfaces, so that you can use a different implementation. So the Kubernetes dependency is one of them. That's the part that we call the health API, basically. So you can, we provide the Kubernetes one, but you can plug any other health kind of background. So if you are on Google Cloud or using something else, if you're on, what's the name? Fargate, I think it's in AWS. There's also Fargate, or some other thing. You can use something else. It's basically an interface with one method to implement that tells you if the node is alive or not. So it's really easy. If you don't even like, we actually provide a test implementation that's not meant for production, that just pings the node to see if it's alive. Like if you don't have strong guarantees, you can just use that. But that's not recommended for production, because it might just be a network issue and the node might still be up. But it's really like easy to implement your own. And I said there are four parts that you can customize. So one is the health API, where we are using Kubernetes. There is the storage and how where we store temporarily the assignments, the shard assignments, and we also use so we use Redis for that, but you can use whatever you want. We also use Redis to propagate assignments to other nodes. There is the serialization. By default, I mean, we use Cryo, but you can use your own serialization. You can use protobuf, whatever. And the last one is the messaging protocol between the nodes. So we are using gRPC and protobuf, but you can use any other protocol. So those four things are really plug and play. We provide default implementation, but they are really small. Like they are really a few lines of code, and you can replace it with something that matches your tech stack or whatever protocol and serialization you are already using in your own project.
Nice. So I think those are the questions we have right now. Do we want to do a little bit of like a hello world? Is there kind of a simple application we can kind of create to like show this? I know this is obviously, it's kind of getting to the point where you have a little bit of like infrastructure we need for some of this, but I always feel like that kind of helps people like take it from
we can definitely we can definitely do something. Yeah, it requires a few components. Like we can't just do like 10 lines of code and show how it works, but we
Yeah,
can
yeah.
definitely do a small example. Yeah, shall we start from scratch or reusing? Because we have some example project, or we can just start from scratch. I guess
I think, yeah, I think sometimes the from scratch can be great, but I'm happy to do whatever you think is going to be it's going to be best.
yeah, I think we can start from scratch, and we can maybe copy paste some parts from the example projects if we want to be a little faster.
All right, perfect.
All right. So are we gonna use? Are you gonna share your
Yeah, I can
screen
do
or?
either way. Do you want me to share my screen or you want to share
Yeah,
your screen?
yeah,
All right.
you can do it.
All right, let me get this open here. Let's see.
Well, in the meantime, I can answer Adrian's question, like how
Oh,
do
perfect.
the requests get distributed to a certain node? So once the shard manager assign shards to nodes, basically each node has a cached version of this mapping. So that's basically a map from shard ID to URL, I mean an IP address of the node that's in charge of this. So each node has a copy of this. So when a node receives a request from the client, it looks up into this map, cached map, to find to which other node it needs to redirect the message with. And then we use the messaging protocol to send that to the other node. And the other node just have the entity running locally and just feed it to the local entity. Hold on.
Oh, let me invite you to this. I'm just gonna send this to you on Discord. All right. So folks should be seeing I just got our Zymposium project open. And why don't we create a new project here?
Okay, I'm installing the extension. I think last
Yep.
time we did in IntelliJ, I don't have the VS Code one yet.
Yeah.
By the way, all the dependencies, like those 4 different things that you can customize, everything is basically a Z layer. So if you're familiar with Z
Yeah.
ecosystem, that's like pretty natural.
Let's just make sure we got this
So
basic.
we actually we kind of need we basically need 2 different apps. One will be the shard manager, and the second one will be the actual application server. So maybe we can start with the shard manager, because that's going to be really quick, because basically there isn't much to write, because you can just use what's provided by ShardCake. There is just a little bit of configuration.
Okay, perfect.
Yeah. Well, I'm still waiting for host approval, I think.
Oh, let's see. That's weird. I haven't gotten a notification for you. Let me try one more time.
Yeah.
I wonder if I invited you the wrong one. Is that working for you?
Uh,
Still not seeing you.
yeah. Wait 1 second. Open. Continuous. Yes.
Oh, there we go. Okay.
Okay.
There we
Okay.
go.
Yeah, I was approved. Okay. So maybe we should start by adding dependencies actually.
Yep, that would be great. So I created this ShardCake demo project.
Okay, you're using ZO2, I imagine.
Yep, yep.
Okay. All right. I'm gonna load my example project in the background. Okay. Okay, so yeah, we need dependencies. So let me see, example project. Okay. Let's just start with the shard manager first.
Okay.
So you're going to need ShardCake dash manager. And what's the latest version? So yeah, the organization is com.devsisters, I think. The documentation at the same time. Yeah. All right, and the version is 204. Okay. So yeah, let's just start with this one. So now we can you can go to the make a new app, basically.
All right, and we'll call this the shard manager.
Yes, and I'm gonna copy a little piece of code.
And do we want ZO app?
Yes, ZO app default. And then does it work? Yeah.
Yeah.
Okay.
Sure, we have some compilation going here. All right, we're downloading this.
Okay.
Great.
So I just copied. Yeah,
right,
just
I
copied.
think, yeah, let's see.
So as I said, there isn't that much to do here because basically server.run is going to run the basically it's an HTTP server that's using GraphQL, so it's using Caliban.
Nice.
Of course, I use my own library.
Yep, yep.
Yeah, and then it requires a few layers. Oh yeah, I missed the import.
Yeah, I think we're missing some imports here.
Let me just add these two. And we probably need to add more dependencies. Yes, I will. So let me just, so there are 6 things here that we need. The first 2 are just configuration values. So like on which port is our HTTP server gonna listen and things like that. And then the 4 next, there is the pod's health. So this is the one where we in production we would use Kubernetes, but for the sake of our example, we can just use the local implementation that just pings the pod to check if it's alive. For the demo, it's good enough. And then there is gRPC pods. So this is the messaging protocol. Well, I guess we could use gRPC as well. For storage, instead of Redis, let's just use in-memory storage. It's probably good enough for this example. And then shard manager.live, that's just the implementation of the shard manager. So that's the algorithm basically to assign nodes, shards to nodes and rebalance and so on. So you can potentially use a completely different implementation if you want to. So in order to make this work, since we use gRPC, we need to add one more dependency. That is, give me 1 second. I think it's just ShardCake -protocol -gRPC.
Oh, almost.
Yeah.
Like that?
Yes. So that's the messaging protocol. And normally, if we have it, the rest should compile.
We're missing live is not a member of shard manager.
Let me see. What's shown? Oh, because the object.
Oh, right. Okay, let's
maybe a app shard manager app.
Yeah, perfect. That would be helpful. Shard manager app. That's the problem when you use names that are too logical. They've already been used. All right, perfect. Okay.
And all right, and so if you look at, maybe you can look at manager config. Just to, normally the default config is pretty okay for a demo. So yeah, if you look at manager config, the default is going to use 300 shards. It's going to expose the API on port 8080. And then there are a bunch of other settings, such as like timeout, like rebalance interval and some timeouts and so on.
Oops. Yeah, oh, here we go. Yep. 300. Okay, great.
All right, so I think we can maybe just start this, see if it runs well. And if it runs well, we can make we can try to create a. All right, there is a log started on port 8080. Okay, so it's listening. So now it's able to, so application servers can register to it when they start. And then they will get assigned the shards. Typically, if we start one node, it's going to be assigned the 300 shards. By the way, if people are curious, like, what's the relationship between entities and shards? Basically, entities could be, there could be a million of entities. Like entities could be like users or guilds or game table or whatever, whatever the domain is. But there could be millions of users. So if we had to maintain a map for each user to a node, that would be too big and inefficient. So instead, we basically using a hash, we reduce this potentially millions of entity IDs into a fixed number. So here, for example, 300 different shards. And we use a hash function that's always giving you the same shard ID for the same entity ID. So in practice, typically we use a hash code modulo the number of shards. So that gives us a number between 1 and the max number of shards, basically, for each entity. Okay. Okay, so now let's create another app that's going to be our application server. And we need to decide what our entity is going to be.
Any audience suggestions?
Well, we could, I don't know, you usually use like a meetup, like for your example, we could say it's a meetup.
We can do the meetups, or we can do the, isn't it like the gingerbread people or something? And isn't that one of the things you can be?
Yeah, well, in our case, we don't have a lot of different entities in our games. It's basically users and guilds.
Okay. All right. So shall we try to do that?
Yeah, sure. I mean, if we reuse the my example, I think it's using guilds. Yes.
Yeah.
Guilds. So basically, yeah, we can reuse that. Then it's gonna maybe be a little bit easier because I can copy code.
Yeah.
Okay. Okay, so we have another Let me just check. Okay, application server. Okay. So first we need to define what messages our entity is able to receive and process, right? So we are basically going to define seal trait and create some case classes or case objects for what the entity is able to receive and process. So let's make a seal trait called guild message, for example. And then, yeah, a companion object. And let's say we can make a join that takes a user ID. It can be a string or whatever, an int or whatever you want. Extends guild message, and we could do a leave. Maybe we start with that.
Yeah. Fine.
Okay. Or we could also have get guild members potentially.
Yeah.
Okay, and then see if I can help at the same time. Okay. Then we have to extend this entity type. Oh, I need some import. Okay. Well, yeah. So this is going to be necessary and for what comes next. So basically, it defines an entity type and give it the type of message that it's able to handle. And then we have a string that's basically a unique key for this type of entity. So, for example, guild. Okay, it compiles. Yeah, okay. And now we need to define what we call a behavior. That is basically the logic for when we receive those messages, what are we going to do? So the behavior, I will show you the basically the signature for this. Yeah, it's like that. So the behavior is we receive an entity ID and we receive a DQ, that's a ZOQ of a guild message. And then from that, we have to implement a RIO of sharding. I can explain later what it is, and returns nothing because it's supposed to be something that runs constantly.
Yeah.
So
and it's really cool here, just saying like how you're using some of the like type signatures, because yeah, using nothing to express this idea this runs forever. And
yeah.
like this is the DQ, you can only take messages from it. So yeah, it's really cool how everything kind of fits together.
Yeah, yeah. Basically the signature kind of tells you what it does, right? It's pretty clear.
Oh, and we just need some imports.
Yeah, those you know about them. Okay. Just one thing I didn't mention, but so the sharding system will start the entity when it receives the first message. And then you see it's a RIO that returns nothing, so it's always running. But there is a parameter that is after how much inactivity time we can interrupt this this always running ZO and basically stop the entity. Because if an entity doesn't receive any message, we usually don't keep it in memory forever. You can, but by default, I think it's 2 minutes or maybe 1 or 2 minutes. So if during 2 minutes there is no message going to the queue, ShardCake will automatically interrupt that behavior, and it's going to restart it later if there is another message coming again. Okay, so let's implement this. So for now, let's keep the guild state in memory. So we can create a ref that's going to hold our guild state. And basically right now we are just joining and leaving. So our state will be just a set of string, I guess. That's going to contain the list of guild members. So let's create a ref with a set of string. Empty, right?
And this should be this is implementing a member on guild, right? So we should put this in here. Is that right?
No, it's not
Okay.
inside. Well, actually,
Okay.
you can do it, but
Oh, no, no.
it's not
Whatever you
necessary.
recommend. Sorry. Okay. No, go ahead. Go ahead.
Because basically at the end, there are going to be a function and we pass the behavior as just a parameter to the function. But you can totally create it inside the guild object. That works. It's just not necessary.
Okay, got it.
Okay. And then, so, okay, we have a state. So of course, this is an example. In practice, it's not going to be a ref. It's not going to be in memory. It's going to be stored somewhere in a database or in a, because here, if we use a ref, obviously, when the entity is stopped, we're going to lose the string, right? But that's just for the example. Okay. And so now we can take the messages queue. We can take from it. We can flat map and handle our free cases. Yeah. And then we can do at the end we can do forever basically. Or we can also use a stream if we want. Like we can do a Z stream from the queue, and that's basically the same thing. Yeah. Maybe,
okay.
Yeah, maybe I'm just gonna make it a little nicer. Here's set empty of string. Okay. Why is it red?
I think we just need.
Oh yeah. Okay.
Okay.
And then, well, we can implement it. So we can say this. We can say, for now, let's make it like super simple. Okay, yeah.
Yeah. And so
Yeah,
how would
and
we
then,
implement something like this
yeah,
where we need to kind of
maybe,
send something back?
yeah, maybe let's do it at the end. Let's
Okay.
make it work first.
Yep.
And let's handle the reply at the end.
Yep.
Yeah, okay. So let's keep it unimplemented for now. So right now, yeah, messages are just like adding to the state or removing from the state, but not returning anything yet. Okay. So now we have our behavior. Okay. Yeah.
Okay.
Okay. We have our behavior. So I think we are ready to create the actual app. So yeah, we can. Yeah, let's go below that. Let's create a program. Let's make a for comprehension. All right, I'm just gonna copy paste a few lines and I will explain what it is.
Yep.
Okay, so the first thing we need to do is register the entity. So register the entity means it's gonna tell the sharding system we have this entity type guild, and here is the behavior that we want to run when we receive a message for a guild. So this is done by calling sharding.register entity, and you pass it the entity type that we created above and the behavior. And of course, the behavior, the queue must match the entity, the message type that's defined in the entity type. Okay, so now the system knows what to run when it starts an entity. Now we need to register the sharding system. We need to tell the shard manager we have a new node. We have a node that's able to register to receive messages. So sharding.register scoped is gonna basically register to the shard manager. It's gonna send it's gonna do a GraphQL actually a mutation to the shard manager that we started earlier, telling that this node is ready to receive messages, ready to host entities. The reason it's called scoped is because there are separate functions for register and unregister. If you use the scoped one, it's automatically unregistering when the Zio scope is terminated. I mean, is finished. So that's the simplest way.
That's very cool.
Yeah, it's nicer with Zio 2 than Zio 1.
Yeah.
Okay, and then the last one is now we have guilds that can run. So we want to send messages to a guild. So we create this messenger, sharding.messenger, and we pass the entity type guild. And this gives us an object that we can use to send messages. So let me copy one more line. Okay. So we don't have. I think maybe I need to write guild message here.
Yep.
Okay. So guild. This guild has basically two functions. One is send discard. So send discard is a fire and forget. It sends a message, but it's not waiting for any response. And there is a send, just send. That's waiting for a response. So for now, let's just start with maybe just send discard, and maybe we can create another one.
Yeah, if we send get members, we'll at least get it, or we can add a couple, and then we could do get members, and we'll at least should get something printed in the console.
Oh yeah, let's do that. Yeah. Okay, I'll let you do it. So right now we are sending two messages to the same guild. One for we're adding two different users. Yeah. Okay. All right. Oh well, we are almost ready to run that. The last thing we need is again the run function. Yeah. So actually,
right, and then we need to provide an implementation of our sharding.
This.
Yeah, perfect. Okay.
All right. Yeah, I probably need an import.
Yeah.
So it's similar to what we just did before. We are adding a bunch of dependencies. So briefly, so again, there are configuration files. There is the serialization. This is using Java serialization, which is also good for debugging, not good for production. But the advantage is we don't need any dependencies. Storage in memory. There is you can choose a client, an HTTP client. So we are using one using HTTP. We are using gRPC for the node communication, and then there is this gRPC sharding service.live. This is gonna expose a gRPC server that's gonna be used by nodes to communicate with each other. And maybe, yeah, okay. Right. So I think we can start this one.
Okay.
And in theory, it should.
Yeah, exactly. In theory.
Maybe just one more thing. Let's add a Zio.never at the end, because otherwise the program might stop right away. And because we use send discard, it's a fire and forget.
Right, we're not waiting to actually.
It might stop even before the message is received.
All right. So this is the application server. Okay, well, so it worked, right? Because okay, I think I ran it before the Zio.never. So if I run it again, it won't terminate, I think. But let's do that one more time.
Yeah, and
right, that's kind of.
Yeah, that's because it's a fire and forget. So the three messages basically are going at the same time.
Exactly.
So once we change it to like receiving a response, we will it will guarantee that we can wait that join user 1 and join user 2 are actually done before we continue. But one thing you can show is, can you show the logs of the shard manager?
Yeah, I think so. This is, oh, yeah, lots of stuff going on here.
Oh,
Let me make
actually,
this bigger.
yeah.
Are you able to see that?
Yeah. So you can actually see that you can see the message registering pod and then localhost and some IP address. And then there is a shard assign. And then there is basically, so we are using 300 shards. So basically it's telling you that all these 300 shards were assigned to that node. And you can see below there's also unregistering. So that's when the process stops. It also unregistered to the shard manager. So this is basically showing you like what happened under the hood, because so I think that if we have time, there are two things we can do.
Yeah.
One thing is adding the response, and the second thing is try to have two nodes, because with one node we are not actually getting, much of the benefit.
Yeah.
Let's do the response first.
Okay.
Because it's gonna be a little nicer.
Okay.
Okay. So to implement the response, in the join message.
Yes.
Here. Okay. There is this class, this type replier. So if we include a replier, we're going to be able to respond to that. It's a replier of A being the response, like what are we responding. So let's just use unit. Let's make it simple. So let's say join and leave return unit, and then get members will return a set of string. Oops. Ah. Okay.
Okay. Yeah, and then that'll give us what we need.
Okay, and then in the implementation, we can just call replier.reply with the whatever is the type. So for example, here replier.reply, and it was unit here, and we can still keep the log, but or we can do flat map replier.reply.
Yeah, no, we don't need that. Yeah. Okay, and so yeah, this replier looks at a metadata object that allows sending a response back to the sender. And so that, I bet if we click through, it's a very simple thing. It has literally one method that is reply, which is lovely. Yay.
Yeah.
Okay.
The replier, and it replies.
That is very logical. Okay.
And then,
so
like, where do we get that replier in our program? So if I get rid of discard here, and just call send, basically send, I can just do that, because send
it gives me a replier.
Yeah, it gives you a replier.
This is if I want to be more verbose and not as pretty as you're writing it, I can do that, I think. And this.
Exactly.
So I think your way is actually nicer, so I think I'll do it down here, but just so people see it's not magic.
Yeah.
And...
Oh, we need to remove discard here.
Oh, right. Yeah, there we go. Okay, and so now then this one, we can say members, and then we could do co.debug members. And then since we're now waiting, we don't even need this. We can let ourselves shut down after that. Okay, all right, so let's try running this. Ooh,
what happened?
We failed to bind an address. I wonder.
I think it's still, there is the other one maybe still running.
Maybe.
Because if it failed to bind, I'm guessing that's the gRPC port. So it's still there's still a process listening to that port, I guess.
Okay, let me see if I can get this going again. Or let's see. Well, now, all right, this one has. Let's see. Okay, maybe let me see if I can just shut everything down. Well, maybe I need to kill all this stuff. This is sometimes the problem with like running all this in a single application. All right, let's try again here. All right, so let's start by running the shard manager. Oh, no.
Oh, now the HTTP server is also in use. I think there are
Yeah.
zombie processes.
Yeah. I'm just trying to figure out the best way to kill everything. Or do we want to just use a different?
Oh,
Port
or
for this stuff?
we could use a different port just for the as a
Yeah,
quick.
do I want to? Yeah, do I want to just
like
so we can
basically,
get?
let me see. Is it this one? Sharding port. Okay, one sec.
Yeah.
Let me see. Okay, so let's use this, and I guess the shard manager as well. We need to change it, I think. So let's use 8081.
All right.
And then that's URI is from STTP. Import. I think that's okay. I think I cannot. Only you can save. I cannot save.
Oh, really? Okay, I think I saved now. Let me get a compile going here. Yeah, I think we're good. I think that maybe is a lot of data.
Red, or maybe do we need this one? Maybe we need this. Oh, okay. It's red only in only in the
think.
UI.
Let me just get the compilation going.
And in the
Oh no, we do have a positional after named argument. We need to give this what this thing called, or we just can move this to the end.
and I need to change the shard manager as well. Copy. Yeah, import 8081. Yes, that should be okay.
I think. Okay. Why do we have? Somehow we just got two shard manager
Oh wait,
apps.
we have two shard managers. Are they the same?
Did we accidentally create a? I think so. Let's see. Did we change this one? You did 8081. This we didn't change it. So let me get rid of this one. Okay. I think we should be. Okay, and now we just got this URI versus required string. So why don't I just make this a string? Error while emitting.
Yeah, you need that URI. It's STTP because it's a STTP URI, but I don't know why it's not. Why doesn't not accept it?
This should be a shard manager URI.
Because I put the same imports as in my project.
Okay.
HTTP client by context.
Yeah, I don't know why we're getting this error while emitting.
Yeah, those errors are kind of weird.
They
Maybe
are weird.
can you clean?
I literally just did that.
Oh, all right.
No, I had the same thought.
Yeah. Yeah.
Um,
What is this?
that is really strange.
Because we're not even, I mean, this project is not even using any, doesn't have macros and funky stuff.
No, that's why, yeah. I mean, I can go to project root. Clean. Yeah, I don't know why.
Yeah.
Let me
Otherwise,
maybe delete all this stuff. Yeah, I feel like we're having very strange issues. Let me just check the Discord, see if anyone sees anything we're doing
maybe
obviously crazy.
yeah, activity monitor on your Mac and search Java and kill every Java process,
Yeah,
which might actually kill the process that's using the port in the first
yeah,
place.
yeah. I'm trying to do that. Okay, let's see if that helped at all.
Oh,
No.
done. Should we try to let's see. Oh, wait. The copy. Oh, wait, the copy is weird. It should copy something. What was the field name? I think it was sharding port. Let's get rid of this for now. Can you try
Yeah.
that?
Okay, still have these weird errors.
What is this?
I know. Let me follow you. Maybe do you want to just revert back to what we had working? Maybe we've killed enough stuff that we can
Yeah,
get
but
this working.
yeah, I think we.
I don't know if it's okay. So that did solve one of the errors. So I don't know why
Okay.
that was an error. So somehow that, okay, so that was really strange.
Okay.
All right, so let me see now if I can
Hopefully the
run.
ports are not used anymore.
Yeah.
Yeah. Okay.
Oh,
Well.
no. Okay.
Oh.
Yeah. So I thought I killed everything.
Huh. But I really don't understand why adding this makes it not compile anymore.
Yeah, I don't know.
It's just a basic
Uh,
copy. Does it compile now? Can you check again? I added back the
yeah. Let me do
copy.
that. Yeah.
No, okay.
Yeah.
Interesting. I don't know why it doesn't accept
Yeah. Very
dot.
strange. Okay. Okay. Let me see.
Oh, I know. I think I know. Yeah. I think it's the Z layer macro.
Uh,
You have to move we have to create a variable. Yeah. I think I already saw that before. I suddenly remember. Like if I move this into a val, it works, right? Yes. Yeah.
okay. All right. That's interesting. All right.
It's
So we
the
can
yeah,
look
I
at
think
that
it's the
offline.
provide macro. If you construct the Z layer, like I don't know. Yeah. There is something funky, I think, in the in the Z layer.
Interesting. Okay. All right. So we should look at that, but then I guess we should do the same thing up here.
Yeah. So I can do it. config and then bar. Yeah, actually, I had the same issue before, like a few weeks ago. I forgot about it.
All right, well, I guess a good reminder. All right, so let's run this. Let's see if we can now get our shard manager going.
Yep, shard manager is
Okay,
on.
great. And let me create another terminal here. Let's run this. Up project. Oh, ShardCake demo. Okay, and now I'll run my application server. Okay.
Yay. Okay.
Yep.
All right. Shall we try to run a second one just to show that if we start a second one, it's gonna assign like 150 nodes to the second node.
Sure.
And we will also be able to see that if you send the message to guild 1, oh, we remove the log. Like if we add back the log in the behavior, we're gonna see that it's the same node it's even if we have two nodes, it's the same node that's gonna log for both of them, basically, because
Okay.
yeah. So okay, so you added the debug. Well, does reply? Yeah, reply returns unit though, so we probably need to tap.
Oh, yep. Or
So
we can just do the debug there. Yeah.
oh yeah, right. That's the same thing, right?
Yeah.
Yeah.
Let me get back there. Yeah, perfect. Okay, so we got that. And so down here, we want to just send some members to another guide.
No, let's just send to the same guild, but
Okay.
we're gonna run this from two different nodes, and they should
Got it.
both go to the same.
Got it. Okay, so I need to create another application server then?
Yeah,
Or I
that
guess
can
I can.
reuse. It can reuse it can reuse everything basically, except we're just gonna change the. We have to change the config and use a different port. Oh wait. Wait. Let me just check something. What do we need to change? Yeah, we need to change the sharding port to another one because they cannot both listen to the same.
Okay. So let's see. So we should probably then factor out maybe some of this logic into like a model thing that has all
Yes.
this guide stuff.
Yes. Even the program, actually, you can factor the program as well because we're gonna run the same program. Okay, and then our two application servers, they are basically the same except the config is gonna be slightly different. Just the sharding port, basically. I think that's the only thing we need to change. The shard manager URI is the same.
Okay.
And,
So I want to change the port here.
Yeah.
Okay. All right. So then.
And is there the we have to keep we have to add back the zero.never.
Never to keep these open. Yep.
Yeah, to make sure
Okay.
that. Oh well, do we actually need? Oh yeah, we need, because otherwise,
Yeah.
the node 1 will immediately stop, and then it's gonna unregister. Yeah.
Yep. All right. So this first one, we're gonna run application server 1. And then the second one, we're gonna run application server 2.
Okay, interesting. Okay. What happened on the first one? Oh, I can switch myself. Okay. And then on the shard manager, blah blah blah. Registering pod 556. So what happened here? So on the first one, it worked as expected. On the second one, it didn't. Wait, join user one. Yeah, it basically timed out on the second one. Let me see. Probably something we misconfigured. Oh, I see. It's because we are using the memory storage. So the map of normally the map of shards to pods is stored in Redis, and that's how it's propagated between the nodes, right?
Right.
But because we are using memory storage, it is actually not propagated. So yeah, so that's the limit of the demo, I guess. Because unless do you have Redis on your computer? Otherwise,
no, I don't think at least.
okay,
No,
then maybe we are not gonna show the full thing, but in ShardCake, there are two example projects. There is one that is it's basically the same thing that we just did, except there's a simple one and there is a more complex one. The complex one is I think, yeah, it's using Redis. So basically, if people who are watching this want to test, they can find this exact code in the ShardCake example project. And if they use the real storage, not the in-memory storage, then it's going to work with multiple nodes. But yeah, I think that's the limit with the.
Got it. Yeah, fair. Okay. Well, I think this was great. I mean, it's really, it always really helps me to like actually see how to do it and kind of code it myself. Well, especially with the author. Why don't we maybe just check back in on the Discord and then we can wrap up?
Yeah, sure. So yeah, basically, after a little bit of plumbing, the only thing that you need to implement basically is your behavior, which should be your already like existing logic. And then as you saw, the sending of messages is really simple.
This is very straightforward. Yeah, that's very cool.
Let's see. So yeah, any questions? Maybe I should.
And it's nice how you set this up here so that like you have kind of type safety of each of these replies. If you say, well, this doesn't get a meaningful reply, this does, and this has to line up. So that's very cool.
There's a question about, is backend storage easy to implement? Yeah, we can actually show you. If you click on storage.memory, can you go inside?
Yeah, let me, yeah, yep.
Oh, wait, let me go back. Oh yeah, and if you go to just storage, the storage trait, which is just above. There are basically five methods to implement: get assignments, save assignments. There's assignment stream, and then get pods and save pods, and that's basically a map of string to pod, and that's it. So it's basically a simple CRUD. Like get and save and get of an object. The only one that might be a little tricky is the assignment stream, because not everything supports a stream, but like worst case scenario, you can even like query if it's a database, you can query the database with some interval, but yeah, it's super simple. We use the stream because it's the fastest way to propagate assignments to nodes. Like when we, let's say, when we assign a node when we assign a shard to a node, the shard manager is directly going to tell the node that it was assigned a shard, but we are using this stream to propagate to the other nodes. Basically, for the other nodes to be notified that the destination, basically it tells the other node to update their local cache of the assignments. But yeah, you can implement that. Like if you see the Redis implementation, you will see that it's each of these 5 functions is like less than 3 lines each.
Yeah. Awesome.
Did message here go through serialization even though they stayed on the same node? Good question. They did not. Well, the first example, when it went to the same node, they were not serialized. The thing that we tried to do at the end that didn't work, it would have used serialization in that case. There is in the configuration object, in config object, there is a property called, how is it called? I think it's simulate remote pods. It's false by default, but when you set it true, it's gonna serialize even if it's the local pod. So yeah, when it finds that the shard is on the local pod, there is an optimization that we don't go through serialization and we don't go through gRPC messaging to talk to ourselves. But by using this simulate remote pods option, you can at least simulate the serialization, which can be useful. We actually added this recently because we had an issue with serialization that we didn't catch in our dev environment because we only had one node, and we found it a bit too late. So we added this option so that we can be sure that we are testing serialization even with one node. Yeah. There was a question, can I have 2 repliers in one message? No. Yeah, we didn't, like, what I'm thinking, does it make sense? It only, yeah, the send function only gives you one replier, but you can make it a replier of tuple, because basically you reply to the sender, right? You don't reply to a random other location. So it only goes back to the one that calls send, but you can return a tuple or. And by the way, on top of the existing sharding mechanism, a contributor implemented a distributed pub sub on top of that. So instead of just going to a given entity by ID, you can also send a message to all of your pods or only pods that are listening to some topic. And that works using the same mechanism under the hood. So, for example, we use that for example, refreshing a cache on all our pods. So we send the request to refresh the cache to one of them, and that pod basically publishes a message that sends to all the pods, and they all refresh their local cache. That's quite convenient. We also support cluster singleton, so it can start a behavior on only one node across all our nodes. It's also not something that uses an ID, it's just a background process, but it ensures that this background process is only running in one of all the nodes. And if that node is down, it's going to restart it on another one. So yeah, there are a few more things than just communicate by ID.
Is there a way to do streaming replies?
No.
I think that would address Thomas's question. I think that's maybe the more general version of his.
Yeah, we don't have that, but that's an interesting. That could be an interesting improvement.
Feature. Yeah.
Yeah, because yeah, it could be a send stream that would use a different
Right.
RPC, because RPC
Exactly.
supports streaming, so you can definitely.
Exactly. Yeah. I think the existing signature assumes you're going to get one value back, so it doesn't make sense. But yeah, you don't have to limit yourself to that.
Yeah. That's actually a very good idea. And we are using Zio gRPC under the hood, and Zio gRPC is also like we actually use it for gRPC streams, and I think it would be pretty simple.
Awesome. Well, this was really cool. Thank you so much for taking the time. It's really cool to see. I mean, I think this is exactly the type of like kind of building these like higher level libraries that like, I mean, it's kind of amazing other than our little snafus along the way with ports. Like, it's amazing how quickly we were able to like fire something up and get something going that was doing something like pretty sophisticated, but then it was also like pretty easy to look at, and like it used all these concepts we know about of like the type signatures from Zio and scopes and streams and all these other things. So it's really cool to see how it's all coming together.
Yeah, and it's really, yeah, it's very friendly if you are used to Zio, and it's built basically just using Zio libraries. Like I mentioned, Zio gRPC, there is Zio Kubernetes, Zio Cache is used under the hood, Caliban. The only non-Zio one is for Redis, because Zio Redis is not production ready, I think, yet. So I think that's the only one that's not a Zio based library, but otherwise it's all powered by the ecosystem.
Yeah, that's awesome. All right. Well, very cool. Well, thanks so much, everyone, for joining us, and thank you, Pierre, for joining us. I know it's late for you, so I really appreciate you taking the time. And
Yeah,
everyone,
sure.
check out this library.
Yes, thank you for having me, and thanks to everyone who watched us. And if you have questions, you can reach out to me or on the Zio Discord, and also in 2 weeks at the
I know. See you in London in 2 weeks.
A more detailed and hopefully a more streamlined version of it with more examples and nice slides.
Awesome. Well, thanks so much, everyone.
All right, and see you in 2 weeks then in person.
Yeah, see you then. Bye.
Bye bye.